record. Okay, hi everyone. So what we're going to do today, we're just going to go over optimization. Optimization might be problems that we'll see on the free response questions. Because remember, there are only three free response questions now for the AP exam, and they're all FRQs. So these types of questions might be it, because this does take into account of derivatives and combining and doing a lot of algebra too. What does TPP NAD? Wow, ignore. Okay, so a company started selling a new type of smartphone for the price of $160, right? Minus some type of value, 0.05x, where x is the number of smartphones manufactured per day. Okay, this is the selling price. And so apparently every time they make more phones, the price goes down by 5 cents. Okay. The part for each smartphone costs $80, and the labor and overhead for running the plant costs $700,000 per day. Oh my gosh. How many smartphones should the company manufactures and sell per day to maximize their profits? Okay, so we're going to maximize their profits. Now that's how can we figure out the profits? Well, the cost per phone we know is 80 already. So let's look at the costs. The cost to make the phones is $80 times every smartphone that they make plus $7,000 that's going to cost per day. And the idea is this is a day, so that number works for us because that's per day. Okay, you can highlight some word real quick. The company selling smartphones at this rate, where X is the number of smartphones, just so we know that. And each part costs 80. The labor overhead is this. How many smartphones should they sell? Okay, so they sell smartphones for 160 minus 0.05x. Tonight's homework is on this type of idea of reading a problem and trying to figure out how to write one equation. From that one equation, we take the derivative and look for the critical points. Now, how do I figure out profit? Profit is how much I sell it for minus the cost. The profit is how much we sell for minus our cost. So we have an equation for that. We're going to say our profit, let's call that profit y, is equal to 160 minus 0.05x. That's my sell cost. And then, so my sell, and we subtract that from the cost per day. Okay, and you can tell that one cool thing is that we have y on one side, and we have only one variable x here. Right, just let's combine like terms. We're going to distribute the negative. That becomes 160 minus 0.05x minus 80x minus 7,000. So just looking at this number, this is gonna be really negative until I make enough money here to negate that. So that's my highest cost. Let's combine some x's. It's gonna be That's gonna be negative 80.05x minus 7,000. Oh wait, x here. Because if I sell 50 phones, this is the price, and this is multiplied by 50. So, made a mistake here. It's going to be x squared. Anyone have a problem with that? It's like if I sell a phone for $100, how much did I make that day? Well, it depends how many phones I sold. If I sold 5 phones, I made 500. If I sold 10 phones, I made $1,000. So I had to include that X over here. If I only made one phone, using examples, if I made only one phone that day, it cost me $80 of material plus $7,000 in labor. So it still cost me $7,080, even though it was only one phone. So I had to make enough money over here to negate this cost to make a profit. There's also a negative part of it. So the more phones I make, the less money I make. So if I make 100 phones, 100 times 0.05 is $5. So I'm only making 160 minus $5. I'm only making 155 phones, $155 per new phone now. So there's a point where I start capping out. You should make 1 million phones. You know what? Did anyone actually read that post? I know a lot of you guys did reply of the Bloomberg spent $500 million. And if, what was it? And there are 300 million people in the United States. So he could have given everyone just $1 million. That was I think an MSNBC reporter. And after she posted that on her Twitter account, she had to cancel her Twitter because people realized that her math was wrong. Because 500 million, that's not million divided by 325 million wasn't one something million each. It was actually $1. You guys, I'm not sure if everyone caught that. That's America and your math for you. I was born in America. Okay, so negative 0.05 x squared. We have 160 minus 80, so it's plus 80x minus 7,000. Okay, I'm going to factor out a negative 0.5, 0.5 x squared. So we do quadratic formula here. I figured maybe we could graph it. This is a parabola shape. Everyone okay with parabola shape? With a negative coefficient means it's facing downward. So we know it's going to look like this already. So there's a point we can maximize our profits. And the point after that, we start not making as much. Okay. So let's finish the equation. Actually, you know what? Let's just take the derivative. Okay, from this point, y is, I don't know why we're doing this. Y is equal to this equation. This is my profit equation. And when I want to maximize profits, we take the derivative of it. So you want to take the derivative of profits. So one of the cool things is when you hear the word maximize or minimize, it's a derivative equation. You just take the derivative. Derivative of what? Whatever you're trying to maximize. And so I'm trying to not maximize the cost. I'm not trying to maximize the sell. I'm trying to maximize my profit. So we came up with our profit equation, and we just take the derivative of it. Now, before I do anything in addition to this, the derivative, how hard is this derivative here? Pretty easy, right? Pretty fast. So power rule, y prime is equal to negative 0.1x plus 80. To optimize an equation, we're trying to figure out where the slope isn't positive, where it's not negative, but where it's 0. Our critical point equals to 0. So minus 80, then divide both sides by negative 0.1. X is equal to 80 divided by 0.1. That's a negative, is a positive, and that's going to be 800. Now, if I sell 800 smartphones, I'm going to maximize my profit. Afterwards, I'm going to make a little bit less every single time. And just like Charles said yesterday, Charles said that the hardest part is setting up the equation. And I agree. I think the hardest part is always going to be setting up the equation. Like, what the hell are you supposed to do? How do you start the problem? And that's the answer. Answer is 800. Okay. First question, was it hard to glean that this was the cost? It's $80 per smartphone plus daily labor. Was it hard to figure out the sell price? Hey, that's the sell price. That's not hard. The part that I almost missed was that I had to multiply it by X here. Because sure, this is the cost that I would make off each phone. But then you have to multiply by X to figure out how much you make total from selling your phones. And we subtract that from our cost from making each phone and our factory costs. So this is our profit. And then for all optimization, once you have the optimization problems, you raise your hand. Raise your hand. You take the derivative. Okay. Question. Are you typing? Let me stop recording then. Oh no, I'll pause recording. Okay. Oh, scroll down the problem. Thank you. Okay. Problem number 2. A cryptology expert, the cryptograph expert is deciphering a computer code. To do this, the expert needs to minimize the product of a positive rational number and a negative rational number. Given that the positive number is exactly 7 greater than the negative number, find the final product is looking for. What the hell? If I don't say this, I say what the hell to every single problem I read. So in order to do this, he needs to minimize a positive rational number and a negative rational number, given that the positive number is exactly 7 greater than the negative. So let's say x, and let's not get x. Let's say my positive version and my negative, okay? So let's say the positive number is, oh wait, maybe I should switch this. Because the positive number here is exactly 7 greater than the negative. Let's call it negative x. And the positive is 7 greater than x. Positive is 7 greater than x. That seems like it's okay. And we need to minimize the product of a positive rational number and a negative rational number. The positive number is 7 greater than the negative number. Okay. And we know this guy is a negative. So we're multiplying a positive times, so we end up with some product. And the positive times the negative. The positive is 7 plus x, and the negative is just an x. So let's make this up. If x is negative 1, then the positive number is 6. Right? A positive times a negative. Okay, that would be negative 6, let's say. If x was negative 2, that would be 5, maybe 10, negative 10. The number is getting smaller, sure. And when we want to minimize, we want to find the lowest possible value. Okay, so let's say that's my equation. Let's try it. Let's multiply them together. It'll be 7x plus x squared. That's our product. And we want to minimize this. So when we minimize, we say we take the derivative and make it equal to 0. Uh-oh. Oh, that was my not working. Okay. Take the derivative. It looks p is equal to 7 plus 2x. So we want to make this equal to 0 because we're trying to minimize it. Sorry, 7 prime. So x is equal to negative 7 over 2. And yeah, x is a negative number. Yay. Now, we have to answer what they asked. They asked, what does the final product look like? So the product is the positive times the negative. We know that the positive number here, let's plug in negative 7 over 2. So it's 7 plus negative 7 over 2. That becomes 14 over 2 plus 7 over 2. So minus 7 over 2 is 7 over 2. A positive. So the product here is 7 over 2 times negative 7 over 2 is negative 49 over 4. How do you guys feel about that? Plus? Okay, so an architect is designing a composite window by attaching a semicircle on top of a rectangular window so that the diameter is on the top of the window is equal to and aligned with the width of the bottom of the window. If the architect wants the perimeter of the composite window to be 10 feet, the perimeter means the whole thing to be 10 feet. What dimensions should the bottom of the window be in order to create a composite window with the largest area? Okay, as you can see, they use the word largest or smallest or maximum or minimum. All this stuff has to refer to optimization. Find the derivative and making that equal to 0. Hopefully we're seeing that pattern so far. And the crazy part is they didn't give me anything about this stupid window. We know it's a rectangle, so let's label some pieces here. Let's say this is x, x, y, and y. Because it's a rectangle, it's not a square. And for this part, we know it's a regular circle. It's half a circle. And we know the circumference of a circle is 2 pi r, where r here isn't the full x, it's half. So 2 pi over, not over, 2 pi times x over 2. That is the top circumference of it. On the rest of the rectangle, we do not count this section up here, because that's not the perimeter. We're going to add this section, this section, this section together. So the perimeter is made up of the circumference plus 2 of the heights and 1 of the base. So the perimeter is 2 pi x over 2. Wait, let's simplify that because the x's divide out. So it just becomes, save us some time, it's pi x or x pi. I should just do pi x. Plus 2 heights, which is 2y, plus 1 extra x as the base. Okay. And then now that we have the perimeter equation, look, it says maximize, find the largest area. Whoops. Oh, shoot, this is equal to, the perimeter is equal to 10. So we know that this is equal to 10. Okay. Now, what are the dimensions of the bottom of the window in order to create the composite window with the largest area? So we want to find the largest area. Largest area means we're going to have to take the derivative of area. So the area equation here is half a circle, pi r squared over 2 plus x times y. Everyone okay with that, hopefully? Exactly. Isn't 0.5 times the circumference? Oh, thank you. I made a mistake here. Right, it's 0.5. So right here, the circumference is the full circle, and then we're gonna half that circle. So that's over 2 again. Thank you. I only have 2 eyes, folks. 2 eyes. Yep. Thank you. We're good now, right? Wait, what? The circumference equation is 2 pi r, refers to the full circle. We're not using the full circle, we're just using half of it. So that's why we have to divide this circumference by 2. That's why we divided by 2 here. Let's say the full circumference is 4 pi. Since we're only using half of it for the perimeter, we divide by 2. So that's why we have the answer like that. So divided by 2. And then, okay. This is xy. So in order, what should the dimensions of the bottom window be in order to create a composite window with the largest area? Our area of the composite window is half the circle on top times the rectangle on the bottom. Now there are too many variables here. Like, I don't like us having y here. I don't like us having x and having r. There's too many variables. We can substitute some of these variables. If we know the radius, it's just half x. So this is going to be 1/2 pi, and the radius is x over 2 squared plus x. So far, here's a hint. I have x's here. So guess what I need to change the x to? Change the y to. I need to change the y to its own right. I need to make this into an x. How can we do that? With the only other equation that we came up with, that guy here. So this equation will be a little messy. So let's go ahead and change that to a y by solving for y. Let me highlight this just because it's kind of an important equation. So to solve for y, we're going to move the pi x over 2 and the x, and then get rid of the 2. So it'll be 10 minus pi x over 2 plus, nope, sorry, not plus, minus x equals to 2y. Divide everyone by 2, be 10 minus 10 over 2. Maya, let me pause. Okay, so we move stuff over. We move the pi over 2 x over. We move the x over. We're divided everyone by 2 now, and that'll be 5 minus pi over 4x minus x over 2. Move that over. Multiply by 5 minus pi over 4x minus x over 2. And that looks pretty ugly. But our next step is to just take what? To optimize it, take the derivative, right? A prime is equal to, I'm gonna move this out. It'll be 1 over 8 pi x squared. How do I get 8? When I square this, use a different color. When I square this, it becomes a 4, and then that's 4 times 2 becomes the 8. I'm going to multiply this out here over here to the right. That'll be plus 5x minus pi over 4 x squared minus x squared 1/2. To make our lives a little easier to write that. The derivative would be 1 over 4 pi x plus 5 minus pi over 2x minus x. I'm going to add the pi's together. Common denominator would make this a 2 over 4. So 1 minus 2 I'm getting is 5 minus 1 over 4 pi x minus x. We want to make this equal to 0. So let's go ahead and solve for x. 5, -5 is equal to, I'm going to factor x out here, okay? A negative x. Actually, you know what? Yeah, negative x. Negative x, 1 over 4 pi minus 1. Here is a trick. I don't like this fraction, so I'm going to multiply both sides by 5. If I do that, we ended up with a 25 is equal to x of pi minus 4, I think. Oh, sorry, pi plus. That's a plus. Pi plus 4. Why? Because when I took out the negative here, that became a positive. And to solve for x, it's x is equal to negative 25 over pi. Darn it, that's not 25. 25 over negative pi plus 4. Rewriting this, it's 25 over pi plus 4. Now the problem is, let's go back and read the question. The question says, create the composite window with the largest area. So what is the dimensions so that the window would be the largest area? Let me check something here. The dimensions would be x. The y is this crazy equation over here. X off. Hopefully, did I make a mistake anywhere? Yes, I'm a freaking idiot. That's why. I multiplied by the wrong number here. I should be multiplying by 4. 4, 4, 20, 20, and then 20, okay? I was looking at the answer, I was like, my answer is close, but it's not right. Okay, so I know it's an ugly answer, but this x is 20 over pi plus 4. How do we get the y? Well, if you remember on the right here, we solve for y equals to y. So we would have to plug into that equation to solve for y. And that's gonna be a little ugly. Let's go ahead and do it on the left here. 5 minus pi over 4, 20 over pi plus 4 minus 20 over pi plus 4 over 2 equals to y. And that would simplify to be y is equal to 10 over 4 plus pi. Don't ask me how. That's what the answer is. I just don't have time to go over it. Okay. Okay. And that's our y value. And how do I know this? Is because these are the x and y values that would maximize my area, because we say our area equals to 0. And you would have to check if this goes up to down or down to up. We're just out of time. It's 10:54, and I still want to cover some quick questions from your work for today, okay? So this is the homework for optimization. And it's really thanks to this guy in a Dunbar High School that has all these types of worksheets. I can just take them. Yeah. So question number 1, the difference between two numbers is 50. So I'd say x minus y is equal to 50. Find the two numbers so that their products are as small as possible. So x times y is going to be as small as possible. So that's our product. Let's call that p. Now, we want to look small as possible for our product. That's p prime. Look for the derivative. Now, I don't want to deal with 3 variables. No, that's a hint right there. Get rid of one of your variables. Y is equal to, get rid of the x, get rid of the negative. So it'll be positive x minus 5. Plug it in. X times x minus 5. Yeah, good job. Well, I don't know if that's the right answer. X squared minus 5x. Take the derivative, 2x minus 5. Make that go to 0. X is equal to 5 over 2. I messed up. Wait. Oh, thank you, 50. Thank you, Maya. That's what she meant, 50. I was like, what? 50, 50, 50. And x is equal to 25. There you go. Yeah, I can see you guys laughing. Yeah. Okay, let's do another problem. Let's jump to, let's say 3. Just then pause the video next time. 3 says the sum of one number and twice another number is 24. The sum of one number plus twice another number is 24. Find the two numbers so that the product is a maximum. I forgot. Do you know how we said x equals to 25? So that doesn't prove it's the smallest possible. So you have to draw the number line, plug in 25, and see, does it go from a negative to positive? Does p prime go from a negative to positive? And that's how you have to make sure that it is the smallest possible. Okay, so just because we found x, we haven't solved it. Okay. Right. This one, let me finish this real quick. The product, so x times y equals to some product. We want to maximize that product. So changing that over, y is equal to 24 minus x over 2. So x times 24x minus x over 2. You can multiply that out. This is 1/2 of 24x minus 20 x squared. And then we can take the derivative of that. Okay. Oh yeah, it's 202. Running out of time. Number 10, take the derivative of this. 1/2 is a constant. We're going to say is 24 minus 2x. 1/2 is 12 minus x equals to 0. X is equal to negative 12. Okay, positive 12, I'm sorry, positive 12. And then I'm going to check at 12. Does it go from a positive to a negative? Okay, Andrew's asking me to do number 7. The slope of a line is tangent to the curve. This, at what point, at point 21, the slope of a line tangent to the curve blank at point 21 is, so how do I find the slope of a tangent line? Just take the derivative. The derivative is, x and y's are together and implicit. 6x squared minus product rule, 2x y squared plus 2y dy over dx of x squared plus 12y squared dy over dx equals to 0. And then we solve for dy dx. And after you plug in, oh, no, what? You can actually just plug in to save yourself some time. Plug in the 2. Remember how this is 2 and 1? Plug in 2, 2, 1, 1, 2, 1. Right? You can do that. That'll save you time. Number 10, which points on the graph is y prime negative and y double prime negative? So these are types of questions that you actually see on the AP. They'll ask you these. Is it A? Is it B? Is it AB? All these like complicated types of questions, but it's through experience. So what does y prime being negative mean? Or this is negative, that's negative. Right? That's negative, and that's negative. When is y prime negative and concave down? This is concave down. When does the slope negative? This is concave up. We don't care about concave up. So we just care about concave down, and the slope is negative. So he's looking at C right there. I think B is supposed to be like a maximum. The answers are hidden. I don't know where they wrote the answers at all. Okay, thank you. I want to stop this.